So I'm on a train, so it might be a bit loud in the background, but I think I've done a couple of tests and it seems okay. So what I wanted to quickly go over today is basically come back to Grover's algorithm, because I'm kind of not super happy with the current available videos, the ones that I've actually made myself. So let me see if I can find them. So Grover's algorithm, quantum intuition, Grover's algorithm. So I was basically, I've been playing around different. I had been playing before around different ideas on how to kind of understand and break down the algorithm in a better way than, or a more intuitive way than the traditional explanations, right? So let's think of, basically this is that's one thing. So this is Quirk's implementation from Craig. That's one thing. So we'll come back to this later. What I wanted to basically go together with you today. Let me see if I can find this. So here's an explanation of Grover's algorithm. The one from the Wikipedia. That's sort of the mathematical explanation, and then there's like a geometric proof of correctness, which is what's the idea of mirroring the amplitudes using the average amplitude as the mirror part. But basically, you're gonna hear some train announcements. I hope not much loud, but oh come on, can I find mine? I'll just go to YouTube. Go to YouTube. Wait a second. I probably this is my playlist. Sorry, I'm just pausing, and I just pause for a second and switch because the network is not working really well here. So, but basically, I've got these 4 videos, right? Which have been performing quite well in terms of views. First, the Grover's algorithm intuition, part 1, part 2, then sort of the explain without the maths, and then the 2 minutes version of it. This is the one that I was originally the happiest with once I actually worked through that. But I'm not, now that I was watching this again, I'm not super impressed. I'm actually not really happy with this, and it's not to say that it's wrong, but it just doesn't feel like this is a nice way of explaining it. So the way that I was explaining it is, what was that? So I think it was somewhere here where I was like, so let me just quickly, I think it was here. I can say put the volume up. Oh yeah, the notes are really good, I guess. I don't know, it just makes me cringe a bit. Because it was basically saying something like the yeah, yeah. It's just I was trying so hard to find something that would be intuitive. That I think I'm stretching it a little bit here. Because basically what I go ahead and say in the next seconds is that then when you move that negativity somewhere else, and then when you're playing harmonics again, it just tries to go back to the 0, 0, 0, but it doesn't go back there, which I think it's not totally wrong. It's by definition what happens when you do interference, when you have interference effects. But I'm not super happy with that explanation. I don't want this to be a video of me watching myself. But that, I think, where is that? What was saying that? That's the point here somewhere else. Give me a second. Come on, I just talk too much. Oh yeah, I think it's here. So basically, yeah, okay, that's what I meant. I really want to go through this again, sorry. So that will be the first interesting thing to check, if that's still something that meets the intuition that we're talking about before. So when you apply the Harmarts, it basically spreads the, because we're talking at a 3-qubit system level here. That's where the intuition kind of breaks, because if you think about 1 qubit, it's kind of it's a bit of a cringe. I hope the audio is going through well. Let's go ahead with this. Give me a second. That's gotten over 1,000 views. I'm quite surprised, actually. There's not so many there's no bad comments at all. It's just, it's funny. Yeah, that's kind of awkward. It's kind of awkward because, I mean, what we're trying to do here is we're trying to get the amplitude to be... We're trying to turn the phase. So what we're trying to do is we're trying to turn phase information into actual amplitude information. Because you come from the assumption that the element or elements we're looking for are flagged by having a negative phase. So I don't know. It kind of feels. It really feels like that needs a revisit, and that's probably what I'm gonna do for the next videos. I'm just gonna go and revisit that because I think that's key. Apart from the fact that Grover's quantum search seems to be one of those that is kind of hitting the. It's like everyone's searching for that to understand. It's one of those weird things to understand because if you can stay in everything that has to do around quantum machine learning and stuff like that, and you kind of can see how the quantum properties are being used in there, basically to have like a wider, like a bigger search space and all that stuff. But here you're literally using some magic to basically turn that phase information into. So yeah, that's probably. That video is probably going to be a bit awkward in terms of just me kind of going through the cringe of watching this, and it just doesn't make sense anymore. And I would never like. It's so funny because I would just go ahead with like a control Z now, which is kind of okay. It's not what I mean. It's really not what it's really not what Craig is using here. I know I revisited that again. Oh wait a second. It's actually what he is using for the Oracle. Yeah, definitely, exactly. It's the control Z pattern. Um, mm. It seems legit, like the video seems legit, but I kind of feel like that's not. I don't know. It's like first you're flagging. First you're like what was I say? First you're flying 111, then you're moving that amplitude. It's kind of awkward, but I mean, I also have to admit that there's a bunch of different explanations and a bunch of different a bunch of different algorithms or implementations, and so going through through different versions of those, you know, they're each a little bit different. So that what I'm trying to say here is the way I want to approach this. I want to take a look at different implementations of Gödel's algorithm and then try to see really what's the underlying intuition that's applied in all of those. Because this is just a proof of correctness. This is just something that is geometrically nice, but I'm not like that's not explaining. That's not giving you the intuition. You know what I mean? It's just giving you another view that it's easier to talk about than just by the numbers, in my opinion. Yeah, go ahead. Yeah, maybe that's not so wrong. And now we can do that, yeah. I have to admit that the color visualizations in here definitely help to kind of go through that. I don't know, maybe it's not that stupid the way that this is put in here. And now I apply another layer of Hadamard gates, and then it kind of tries to go back to the previous state, which was basically the original state. But it's like why would it even be obvious that this kind of turns into the amplitude being higher here, you know? Yes, sorry, we'll take it back to 0, 0, 0. So is it okay? So what I'm saying here is basically that the negativity belongs together. but this is a question of how does the interference behave in there. And I mean that would be an interesting thing to research. You know, it's like the interference patterns and how do they behave in there, because it's that. I mean, if this is something that can be generalized, then it definitely has a lot of applications. But or I mean, I don't know, not that I can think of any right now. But so what I'm basically saying now is I apply another layer of Hadamard's and the negativity goes back to where it was, but because now there's more negativity, then that basically stays there. Yeah, but it's everything negative exactly. That's so awkward. I mean, that doesn't explain it. It just I just seem to find a way to explain something without really understanding it. It's just bam. That's where it doesn't hold together. I mean, we just because we've added more negativity doesn't mean that now you just have everything negative. That's definitely where I want to revisit that, because I feel the explanation was kind of pointing in the right direction, but I just feel that at the detail level there was some things that don't really hold together, and that doesn't. Yeah, okay. I think that's definitely what we have to explore. So what I wanted to basically do in the next videos is I'll take a look at different implementations. I think I'll even go through continuous variable quantum computing implementation of Grover's algorithm if I can find one, and and then see if I can get a bit more inspired about, like, how to intuitively explain all that. But there's definitely something there's definitely something to do here with the intuition pattern, with interference patterns, and trying to understand how this works. So yeah, that was just a short cringe video about watching my. It's so catchy. Explain without the maths, and I think that doesn't really. I mean, uh, John is the only one commenting, and he's commenting anyway most of my videos. So thanks, John, for being a big fan. But it feels that needs a revisit, definitely. Perfect.